Hey all you cool cats and kittens, this is Mr. Nicholson. I'm going to be doing examples 3 and 4 on the convergent versus divergent sequence notes here. Like examples 1 and 2 that Mrs. Gerber did a nice job explaining whether they converge or diverge, we're just going to look at it from a different perspective. We're going to look at it from the explicit formula side of things. And so what we mean by that, hopefully you all did the sequences reading. I'm sure you all did that. But at the bottom of that, we have our sequences in our explicit formulas and summarized really nicely. So go ahead and take a look at that if you haven't, or if you did and need a refresher. You take a look at that and you realize, based on those notes, that the first example is arithmetic, and the second one is geometric. Again, take a look at the notes if you don't understand how we got there, but we're just looking at the formulas and their format. The next thing we need to do is determining from that, how do we know, is it converging or diverging? And it says at the bottom, so we'll start with the easy part. Feel free to use your graphing calculator to help you. The question really is, we want to kind of get a set of numbers like we did in 1 and 2. We want to see, are these numbers trending to a particular point or value, or are they just getting exponentially bigger or smaller? And so if we plug in n is 1, 2, and 3, we get 34, 37, and 40. If we do the same thing for number 4, we plug in n is 1, 2, and 3, we get 100, we get 50, and 25. So maybe that's not quite enough information, but we could look at this and say, well, we're just adding 3 every time. And what that means is we're not ever going to head to the same, like any particular value. We're just going to keep getting bigger and bigger numbers the further out we go. So this one, we would say diverges. Because no matter how big or small the x term, or in this case n, gets, we're never heading to any particular point. On the other hand, question 4, it's geometric, and geometric will almost always have some sort of a pattern. But the thing is, if this number in the inside here, if the number that we're raising to an exponent is between 0 and 1, what we're really looking at is taking a fraction to an exponent. And anytime you do that, like in this case, 1 to an exponent and 2 to that same exponent, the 1 is always, no matter what, it's going to stay 1, because 1 to any exponent is 1. The bottom number, in this case 2, is being also raised to that same exponent, but 2 raised to any number is going to get bigger and bigger and bigger very quickly. So this is actually going to tend towards 0, because 1 over a big number is tending towards 0. So if you take 0 times 100, we get 0. If we were to look at these graphically, well, let me answer this one. This is that. Make sure that's red. This is converging to 0. Now let's confirm this graphically. If we wanted to graph the first equation, which I happen to have in y2 here, I'm going to graph that example 3. What happened to 3? Oh, we turned them both off. There we go. All right. So as you can see, as this x, or in our case, it's really n, as it's getting bigger, it's just going to positive infinity. If it's getting smaller, it's going to negative infinity. That doesn't tend towards anything. So that kind of confirms this idea that it diverges. Here, our geometric series can diverge, but we really have it, in this case, converging to 0. Let's confirm that. We'll turn this on. We'll turn that one off. And there's our graph. See, as our fraction is being raised to an exponent, it's getting closer and closer to 0 times 100. And so here we are, very quickly approaching 0. So we would say it converges to 0. So there's your examples. Hopefully that helped. And If not, or if you need more explanation, please contact your local honors pre-calc teachers. Thank you.